Have you ever wondered how pilots determine the appropriate liftoff type during takeoff, or why they may have to reject a takeoff, and whether there is a specific moment during the takeoff roll by which they must do so? If you've pondered any of these questions, stay tuned, because this is exactly what we'll be exploring in this video. Welcome back. In this video, we will delve into an interesting and quite an important topic, and it's concerning takeoff speeds. In aviation, speeds are typically referred to as V speeds. Interestingly, the letter V actually stands for vitesse. It's the French word for speed or rate. Although most people assume that V stands for velocity, which is also quite correct. V speeds are a set of airspeeds that are critical to ensuring the safe operation of an aircraft. Defined by the authorities, pilots must use them to ensure that they are flying within safe operating limits. Although there are many V speeds, we will specifically examine the various takeoff speeds and their significance. The actual speeds represented by the V designator are expressed as indicated airspeed, which allows the pilots to read them directly from the airspeed indicator. If you wish to learn more about the different types of speeds, you can do so by clicking on the video above or the link in the description below. So let's dive into the takeoff speeds that are critical to flight safety during takeoff. The first V speed is V1, which is the takeoff safety speed, or the go, no-go speed. This is a maximum speed at which pilots can initiate or reject a takeoff in the event of an emergency. V1 is also the minimum speed at which pilots can continue takeoff following an engine failure. If an issue arises before V1, pilots must abort the takeoff to ensure the safety of the aircraft and its occupants. This will ensure that the aircraft can safely stop within the remaining runway length, also called the accelerate stop distance. Now, whether to reject the takeoff before V1 depends on the nature of the problem and the aircraft's speed, and it is usually at the captain's discretion. For certain problems such as an engine failure or a fire warning, a takeoff must be rejected if the speed is still below V1. After V1, the pilot is committed to continuing the takeoff even if an issue were to arise, as stopping the aircraft on the runway would be unsafe. Reasons why pilots might reject a takeoff include a technical malfunction in an aircraft system, or perhaps they may have encountered a wind shear, which is a meteorological phenomenon that involves sudden change in wind direction and or speed. A rejected takeoff may also be carried out on receiving an air traffic control instruction, or it might be rejected if there was any indication that the aircraft will not fly safely. The next speed we will discuss is VR, which is called the rotation speed. This is the speed at which the pilot makes a control input to lift the aircraft's nose up to take off. Pilots must know the speed to ensure that the aircraft lifts off the runway at the correct angle and speed. Once the aircraft is in the air, the next speed is V2, which is the takeoff safety speed, and must be maintained up to acceleration altitude. So the altitude at which the aircraft begins its acceleration to its climb speed. V2 is the minimum speed at which the aircraft can safely climb with one engine inoperative or an engine failure. In the event of an engine failure during takeoff, assuming that it occurred after passing V1, the pilot must maintain the speed at a minimum to ensure the aircraft can safely climb and clear any obstacles in its path. All the speeds we've reviewed vary depending on the aircraft's weight, its configuration, in other words, slats and flaps position, the runway length, and other factors. To recap, V speeds are critical to the safe operation of an aircraft. These speeds provide the pilot with a set of guidelines to ensure that they are flying within safe operating limits. The different takeoff V speeds, including V1, VR, and V2, all have significant importance in ensuring the safety of the aircraft and its occupants during the takeoff and initial climb. On a side note, the three speeds we've just discussed are governed by some other V speeds, such as minimum control speeds and the maximum brake energy speed and so on. However, without delving into deep complexities, V1, VR, and V2 are the three speeds that pilots calculate and use for every takeoff. Alright, so there we have it. We have reviewed the takeoff speeds that pilots commonly work with and discussed their significance. You see, takeoff speeds are a safety key element for takeoff and enable pilots' situational awareness and decision making in what is a very dynamic situation. The use of incorrect speeds at takeoff may result in problems such as early rotation, aircraft tail strike where the tail hits the runway, collision with obstacles, loss of control, or runway overrun. In fact, there have been serious incidents and accidents in the past where the takeoff resulted in a tail strike and collision with obstacles because of pilots using incorrect takeoff speeds. Takeoff speed calculation errors are often due to a combination of two factors: error in parameter entry and or poor cross-check by other crew members. And to mitigate the risks associated with the use of incorrect speeds, airlines have developed prevention strategies which ensure efficient cross-checks of takeoff performance data between crew members, particularly during the departure briefing or after last-minute changes such as a runway change or a load sheet modification. In case you're wondering what a load sheet is, this is a document that's prepared for every flight and is quite important as it outlines how the aircraft has been loaded and its weights. So the takeoff weight would be one of the weights indicated on the load sheet and would be used to calculate the takeoff speeds. Also, modern flight management systems, or the FMS, can tell pilots if the speeds entered in the FMS are incorrect for the weight of the aircraft, thereby prompting the pilots to check the speeds. As alluded to earlier, the use of erroneous takeoff speeds can lead to issues like tail strikes, collision with obstacles while trying to lift off, high-speed rejected takeoffs, or initial climb with degraded performance, therefore rendering the flight unsafe. As it can be inferred, the understanding and use of proper takeoff speeds is critical to flight safety, and effective measures need to be in place to ensure the use of the correct speeds for every single takeoff. Alright, so that was a high-level overview of the different takeoff speeds. Takeoff speeds fall under the subject of aircraft performance, which is actually a bit of a complex subject, and we've barely scratched the surface when looking at aircraft performance during takeoff. But this video is just meant to be a high-level explanation of the different speeds that pilots work with in a practical sense, and I hope it made some sense and it wasn't too difficult to follow. As always, if you have any questions or comments, or you would like a certain topic related to aviation or flying covered, please put that in the comments below and I shall do my best to cover that in a future video. Well, thanks very much for your time and support, and I look forward to seeing you in the next video again soon. Thanks again, and I wish you a great day.